If I have y equals to a sine bx plus c, let's say, okay, transformation of the sine graph means that this is known as my amplitude change. This is known as my period change, where my new period will be 360 over b. And this over here is my vertical shift. In which case, if I have some kind of original function of sine, all right, so let's just shrink this up and keep it on the side there. If I have some original function of sine, like this, so this is going to be, let's say the sine graph does something like this. So it goes up, down, and then back up again, like this. One more time. There we go. That's enough. And this is 360 degrees. That's the original sine graph, right? Let's suppose I want to draw a new sine graph. And the one that I want to draw is y is equal to 2 sine a half x minus 1. Okay? All right. The first thing I have to remember here is that I have I have some kind of vertical shift, which is going to be down by -1. Okay, we can see that's going to be the vertical shift there. And if that's my vertical shift, let's start from there, because that means that the whole graph is not going to start anymore here and end here. It's going to be one down. Now, at the moment, one down is over here. So this is going to be my new central axis or central x-axis from where the graph is going to rotate around. Okay? I'd like to extend this as well a little bit down. I'm going to extend this a little further. And now, also don't forget to label your y and your x. So let's label y over here and x over here. Now that's the vertical shift. From here, I am now going to go up 2 as my amplitude. All right, so I need to go up 2 as my amplitude. So from -1, if I plus 2, I end up at 1. And if I minus 2, I end up at minus, so this is -2 to be -3. All right, you can see that's where we need to go. So let's put this down. So it's -2, there's -3, and over here is 1. The amplitude at the moment is 1. Y equals sine x. I'm now doubling the amplitude so that it goes the other way. But at the same time, I've changed the axes. So I've already changed the axes. There's the dotted line. I now need to remember this is the height of my new graph. And this is the lowest point of my new graph. It's going to have a total distance. Remember, carefully looking at this, the total distance from here till here is my amplitude, and from there to there is my amplitude. It's going to be the number 2. All right. Now that I know that, what I want to do now is we've got our highest and lowest point, right? Remember, that's your amplitude or vertical stretch. Let's look at a half now. The period is given by taking 360 degrees divided by this number, whatever this number is, by b, right? You can see over there. So that's going to be 360 over half, which is going to get you 720 degrees. So that's 720 degrees. This is one full cycle. One full cycle like that's going to be needing 720 degrees to do. So we got 180, 360, 540, and there's 720 degrees there. All right, so the full cycle is going to be till there. And I'm now ready to sketch my graph. I'm ready to sketch my graph. All I've got to do is remember that this is my starting point because that's the vertical shift. And I've got to go as high as this. This is the ending point over here, and this is the middle point of my graph. This is my new axes, if you have to think about it. But the graph's going to do something like that. The height of this graph is going to be there, which is halfway between these two, which is 180 degrees. And halfway between these two would be there. Now I'm sketching this. Obviously, it's not to scale, but that's how the graph would look. And it would come back down, turn back there, and stop there. And this is now that graph over there. How do I know that this is correct? I can do a quick check around. I say, oh yeah, okay, well, my amplitude looks right. It's 2 and 2 this way. So that's all good. So I can definitely see that that's good. And I can see that a half implies that my period is no longer 360, it's now stretched to double 720. And my vertical shift of the whole graph is down by 1. So everything is centralized around 1 point down. And that would be the graph that we're looking for there. All right. So that's 360 degrees divided by a half. All right, so that's not 112 over there. So this is a half. I should just rewrite this a little bit neater. So this is a half over here. So it's 360 divided by half, which implies that it'll be 720. How many halves in 100? 200. So how many halves in 360? 720. We just double it. Okay, and that'll be that.